The outside of the transformer is not much to look at. The high voltage bushing. It's here that the 25,000 volts arrives. The body of the transformer is just a plain steel cylinder. Finally, there are 3 low wattage bushings. The 120 volts that runs practically all your household appliances comes out here, along with the 240 volts that runs your oven and dryer. So how do you chop 25,000 volts down to 120 and 240 volts? One word: induction. It's fascinating and really simple. Here's how induction works. The current comes into the transformer and shoots into a copper coil. It's the primary coil. That current generates a magnetic field, and if you put a second coil within that magnetic field, an electric current happens in the second coil. That's induction. Now, if the wire is wound around the secondary coil the same number of times as the primary coil, the current induced in the secondary coil would exactly match the current in the primary coil. But if the wire is wound around half as many times, you get half the voltage. It's as simple as that. The coolest thing about induction is that all this happens without ever having the 2 coils touch each other. You can chalk that up to the science of magnetism. In this model of transformer, magnetism has a few more surprises. The first surprise? The transformer contains exactly 18.5 gallons of oil. The second surprise? The coil's copper wires and aluminum leaves are covered in paper. Surprise number 3? There isn't just one secondary coil near the primary coil. There are 2. Don't worry, we've got it covered. So, why oil? It's an excellent insulator and prevents humidity from getting into the transformer. In a nutshell, it protects against short circuits. Since it doesn't conduct electricity, its job is to insulate the components from each other. No argument here. Paper inside a transformer does seem a little strange. But paper soaks up the oil, allowing it to get in between the transformer's tightly packed components. Let's go over it. The metal leaves of the coils never touch. They're insulated from each other thanks to the oil-soaked paper. No short circuits to worry about. The 25,000 volt current surges through the primary coil, generating a magnetic field in the metallic core surrounding the coils. An electric current is induced in the secondary coils. But why 2 secondary coils? Well, because of the number of times the wire is wrapped around the coil, each one generates 120 volts. 2 means they can be combined to get 240 volts. And all of this without any of these components ever touching each other. Oh, induction. Simple, efficient, safe. Induction. There's only one thing left to explain. That constant buzzing. Time to cash in my fancy word coupon. Magnetostriction. It sounds complicated, but it's super simple. It means the metal's vibrating thanks to the alternating magnetic field caused by 25,000 volts. An alternating magnetic field just means its direction keeps reversing itself. With every direction change, the metal bends and regains its shape over and over again. Now you know what all the buzz is about.